Guys, how's it going? So today actually we're going to be looking at JSON Web Tokens, JWT, and we're going to be analyzing if they could be risky or maybe they could actually increase latency for your application. So before we get into the demo, I thought it would be a good idea to kind of walk you through the traditional ways we used to authenticate the users and walk you through a high level design of how they work. Then we're going to come back into the implementation. So without wasting any time, for those who are new to the concept of JWT, in simple terms, we can think of this as like we're trying to authenticate our users. So we do this by sharing security information between the client and the server. So this information that we share, for instance, like let's say we have a client here, right, the user, and they log in into our system, right, and the backend is going to generate a token. And this token, like I said, security information, it's going to be used by the client to access our different services, right? This could be payment. This could be adding a product to a cart, right? So the point here is that we don't want them to log in every time just to authenticate them. So we want to always use this token to see if these users are verified to access these services, right? So this is also called that digitally signed. So what I mean here is that JWT essentially it's going to check if the user is authenticated by checking its signature, right, against a known secret. So we create a secret on the back end, right, and JWT is going to use the secret, right, and it's going to check its own signature to check if I'm the one who generated this token. And this way it will know that, okay, this user is authenticated. So we're going to get into the complexity of how this works in more detail. But for now, I'm just giving you an overview of how it works, right? So that you kind of have an idea as I'm explaining some of these concepts. So some of you might be like, yeah, but these robust services like AWS, Azure authentications and stuff, why don't you use them, right? So we're living in the world of microservices, right? Whereby we can have multiple services whereby we can create APIs within these services and they need to be authenticated, right? So it's not only about login, it's not only about logout, right? So whether you're a data engineer, I think you're working with API, whether you're a machine learning engineer, you're creating machine learning services and stuff like that. So at some point, you're going to have to authenticate your APIs, right? So I think this concept is quite good to understand. Okay. So we're going to walk through a traditional workflow for how things used to work. I thought it would be a good idea to walk you guys through some sort of a traditional way of doing things. Mainly because I think you will appreciate JWT more, and I think this might help us to see maybe some of the bottlenecks JWT might have. So let's think of we have a client, right? We have a client and we try to log them in. So the client obviously is going to send us the username and the password, right? And in our server session, what we try to do is that we're gonna create a token and store that token along with the information user into some sort of a database. Okay, so after we've done that, so we store the session information. I think here we should have authenticated the user. It was a login, and we store information in the token, right? We send the token to the user, which then the user will use in the session to access other services. Okay. So let's say now the user wants to access, maybe they want to add a product or so. So we still have a client. So they're gonna send us the session token, right, that we gave them. Then what the server will do then, it will try to send the token to get the information, the user information. So it sends the token to the database, right? So DB, then this DB will return the user information so that the server can be able to authenticate this information. Okay, because the user was trying to store the product, right? We then, the last step is to perform their action, which is product store. Then we send a success status to say product added, right? So what is the problem with this architecture? So one could say that obviously because we're storing the database, right? The database we're getting information, so we're making too many calls to the database. So the latency increases for application. Because every time we have to, store the session and send the token. You see how many calls we have to do. Send the token, get information, user, the server has to authenticate, perform that. So there's just so many steps that we need to do. So this increases, it makes our application very slow, right? So one way one can say we should solve this, right, is to say, okay, let's just try to think of ways we can reduce the DB lookup, right? So so how can we reduce this? So we can probably say that, what if we store this token in the server? We store the token in the server memory, and in server memory, right? So that's one way. But the problem with this is that in a distributed, where we're building distributed systems, right? So each server is going to have its own, it's going to store a set of tokens. But then when the user log in, like let's say the user log in, and when you try to direct them to a different server, then the token will be stored in this server. So then it's going to become a problem. So that means they will have to log in again. So that means it makes the point of JWT also pointless. One way we can also think about is that because we're storing the tokens, for how many users do we have? So obviously because of the memory of the server is coupled together to store the token, then we see that we're going to have a memory overhead, right? So that's the first problem. One can say maybe we can tell the load balancer to send traffic to a specific server, right? So maybe we can say, okay, load balancer, send traffic to a specific server. But also this makes scaling pointless, because now if the user are going to access a specific server, then we can overwhelm our server with multiple requests, and some of the servers might not be utilized to their full potential, right? So okay, JWT tried to eliminate these problem by actually saying that, okay, we can store user information, right, along with the token itself, right, and create a secret known to the server, right? So the point here that I'm trying to make is that, just making the same example, is that we can think we have a client, right, and then the client tries to log in. Obviously they send us the user password, and then in our server we authenticate them just to see if the user exists in our database, right? We send the user the token. So just can you see that we don't make another request here to store the token? No, we don't do that, because the next step, what's going to happen is that we going to, on the server, we're going to validate the token on the server itself, right? So we verify it here, then we just send the product, we just store the product that the user wanted to store, right? And we send the success status. So the point here is that this JWT, we have a secret that is known only to the server, right? And we use JWT algorithms. So this algorithm, some sort of like check its signature to make sure that, okay, I'm the one who generated this token, and then it check the secret also, right? And it gets the user information from there. This could be maybe ID or something like that that is being stored in the token. Then it store that product into the DB and send us our success status. So in a distributed systems, what we can do is that we can distribute the secret across the servers. So the secret is here, secret is here, secret is here. So even if we try to send a request to this, it will still be authenticated, because each server has a secret that the JWT can use each signature in the secret to be able to see that the token was generated by it. Okay, so that's the point essentially. Giving you a more visual example, we can see from this visual, can I zoom in? So we store the user information in the payload, right? We store user information in the payload, and then given this token here, the encoded token, right, we can decode it, the server can decode it to get all of this information, and we can know all this information, like the user, this people refers to the payload, this refers to the signature, this refers to the header information, and we can get all of this and can authenticate the user. Okay. However, the problem with this is that, can you see, like, we're sending so many information in a JSON format, but JSON is quite expensive, right? Meaning that in a way, by expensive I mean like because we have more information to send, so it can add up to the latency. So I mean, like, if you compare this to something like RPC, right, we know that maybe RPC can be faster than using something like JSON. That's the point that I'm raising here, right? So another point that was raised by the Redis Redis was that in most cases, if you block the user, right? If you block the user, then you don't necessarily block them because of the token has expiry time. So immediately when you block them from the system, but their token is not yet expired. I think there's a workaround this. You can still manipulate the expiry time of the user to be, let's say, their current, just to make sure that like it just to make sure that it expire or something like that. So I'll show you in the code how it's done now, right? I think there might be a way around that. So another point that they raised was that JWT libraries had a security issues. I think also on the Y combination I saw a thread around this. So there could be security issues around some of these libraries. So because of like problems such as like these, how could we then come up with like an architecture that can help us to overcome these problems, right? These might not necessarily be problems for other people, I get that, but what is the workaround? Because if like you care more about latency and you know that, okay, from a JSON perspective, you have more information stored in a JSON, and so because of that, this increases your latency, your bandwidth. So you want a solution that can still be fast. So how can we generate something like that? We can probably say, okay, how about we introduce some sort of like a blazingly fast database. So what I'm saying is that, okay, let's say we have a client, like same use case, right? So they try to log in by sending us the username and the password, right? And in the server, what we do is that obviously we need to authenticate them. So we're gonna have to query the database directly. It's a slow database, could be MySQL, but we store the token and the token information, like the user information, sorry about that. We store the token and user information inside some sort of like Redis, a memory store database, right? Then we send the token to the user, right? So when the user come back and try to then maybe upload a product, so they give us the session and they give us like the product that they want to store. It could be product ID. Then in our server, what we do is that we want to authenticate the user. So what we're gonna do is that we're gonna send the token into a blazingly fast memory store, right? The blazingly fast memory store will then send us the user information that will then authenticate against the server. Okay, then we do the slow thing, which is to, I think this is done everywhere. It's just to store the product ID, right? And then we send the success status. The point here is that we can eliminate some of these problems that we spoke about by having a blazingly fast database to store the security information. Okay, so credit to Redis. This was their architecture. I'll have to like test this. So I think in my second video, I might test this and compare performance between JWT and and we'll try to make it more like try different use cases, even like if we have like more information in the JSON, try to see so that we can create some sort of like we can actually understand if like there is more advantages, right? So yeah, I think that's what we're gonna do. So try to mimic the behavior as I was explaining. So like we said that we're gonna log in the user or register the user. So when we do that, we know that we take their password and email, we try to store them into our database, and we send them a token, right? So this token that we send them is gonna be used across different services so that they can authenticate the user. They don't have to log in. This behavior will also do it when the user tries to log in, so that they log in, we check in our database that the user exists, then we send them a token that they can use to access other services. So what does this send token does? Essentially, what it does is that we try to call this method called get JWT tokens. So what this does is that it creates a signature for the user, and it takes the secret. So you can think of this signature that has been created, and the secret is going to be used to authenticate the token. So this function generates a token, right? And then this token is going to be stored in the payload. And as we access other services, it will be adding card, which we're going to get into. Then what we need to do is that we need to authenticate that token. So this is where we're going to use the secret. We're going to pull this secret again. Okay. So what we do after we get the token, right? After we generated the token, is that we try to now set an expiry date. This could be 7 days, so it could be a day, depends on the use case. We send this token into the cookie so that other services can get the token from the cookie. And it's important for you to know that we store this token along with the user so that we can get the user information much easier. So this actually enables us to say, okay, if now the user make a payment, we can see that, okay, this user can get the user ID, something like that, right? So that's the point we have to store along with the user. So with that, now let's look at an example. Let's go to product controllers. So now that the user has been authenticated, which I'll show you how we do that, given that we have generated their token. So they can be able to access some of the services, like maybe let's say they want to get a product. Maybe they say they want to create a new product. So sometimes we do get the user information from the token. So that's the advantage of that. So now I want to show you how we then know that this user is authenticated. So if now we go to our middleware and we select routes, actually let's start with routes. So we can say products. So what we do is that if now the user go to a site like the service called products, we call this function called is authenticated user. So what this function does is that it will let's get here. So what this function is that it will try to get the token from the cookies. And if there is no token, it will tell the user to register or maybe to log in. Then, like I said, what we do is that we take that token and we verify it against the secret. Then we know that, okay, the user has been authenticated or something like that. So essentially that's like the whole entire thing and how it works. I think I'll try to create a new video as a follow-up to compare like this implementation and the one whereby we use Redis to store the token. This from an application's point of view. So let's say that I'm trying to register. Now on the website, I'm passing my name, I'm passing my email, and I'm passing my password. Then I'm gonna send this, make a post request, then this is going to be a success, right? Then what will happen is that I have these tokens generated, and don't forget that this token has some sort of, it's an encoded token, so it has like the user information, it has like the header, I think also the payload and the signature, like I showed you in the demo. So even if we try to log in the user, we can try to log in the user. So we are logged in, we generated the token. The good thing about this is that because now we have a token, if we go to like services like get product and we send this, we don't have to log in because it's gonna use the cookie that we stored here to receive the information. Now I have like the product, price, I'm getting all of that information, and mainly because it already done the authentication through this. And like I showed you in the route, that if you pass this route, we call that function called is authenticated. So that's how it works, guys. I hope you enjoy this. Like I said, I'll create a follow-up video to compare the Redis implementation and see compare the time and like the time it takes and the latency and stuff like that. It will be interesting to see. Yeah, just to kind of like learn also. I think that's important. So yeah, thank you guys for watching to the end. I really appreciate it. Bye.